3.2 polynomial functions of higher degree. I'll let you go ahead and look over this page in your notebook on your own. And then looking at the bottom part, these are names for polynomials. If you want to look over this chart, you'll remember some of this from last year. Then looking at example 1 and example 2, if you want to try these on your own, and then you can check this for solutions to see if you were correct. And then if you have any questions, please ask me in class for example 1 and example 2. These are both review problems. The leading coefficient test is used to predict end behaviors of polynomial functions. We have two types, odd degree and even degree. If the polynomial function has an odd degree, then the ends are going to go up and down. They're going to go opposite of each other. If the degree is even, then the end behaviors are going to go together. So both up or both down. Now, how you determine which graph you have is based on the leading coefficient. If the leading coefficient is positive, then you're going to have the right side up and the left side down. How you write this is the limit as x approaches negative infinity. This means as I go left, 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 f of x is going down to negative infinity. The limit as x approaches infinity, which means as I go right, 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 f of x is going up to infinity. If the leading coefficient is negative, then the limit as x approaches negative infinity, as I go left, I'm going to go up to infinity. And as I go right, I'm going to go down to infinity. Even degree. If the leading coefficient is positive, then f of x is going to equal infinity when you're looking at the limit. And if the leading coefficient is negative, then f of x is going to go down to negative infinity on the left-hand side and the right-hand side. I recommend you try example 3 on your own, stop the video, and then check your answer. Example 3 is indicate the degree. So you're going to let me know if it's odd or if it's even. And then if the leading coefficient is positive or negative. So looking at this, because we have one side up and one side down on the end behaviors, we know that the degree is odd. The leading coefficient, because the left side rises and the right side falls, we know that the leading coefficient is negative. Let's put neg. All right, looking at the second one, because the end behaviors are together, they're both going up, we know the degree is even. And we know that the leading coefficient is positive because we're going up and not down. Looking at zeros. So zeros, if you recall, if x equals a is a 0, that means when y is 0, we get a, then it is called a 0 of a function. It's called a solution of the polynomial function. If I write the 0 as x minus a, it's a factor of the polynomial function. And if I write it as an ordered pair, a comma 0, it's an x-intercept of the graph of f. So looking at zeros, we have two types of multiplicity. Multiplicity is repeated zeros. So that's when you get the same solution more than once. If it's an odd multiplicity, we're going to get a swish. It's going to go through the 0. If it's an even multiplicity, we're going to get a bounce at the 0. And over all of the definitions, let's go over an actual example. So example 4, it wants us to sketch the graph of g of x. A sketch is not going to be an exact graph, but it's going to be close enough. So this is in factored form. Because it's in factored form, this x minus 2, I have 3 of those. It's x minus 2 times x minus 2 times x minus 2. And x plus 1, I have 2 of those, x plus 1 times x plus 1. So if I were to multiply that all out, I would end up with 5 x's. So the degree is 5, and that is odd. Because the degree is odd, I know that one side is going to go up on the end, and one side is going to go down. Now the leading coefficient is this 2 in front. And so the leading coefficient is 2. 2 is positive, and so I know that my end behaviors, the left side is going to fall, and the right side is going to rise. So that's my hint about the end behaviors. The next thing I'm going to do is I want to find the zeros. And in order to find the zeros, all I have to do is take the factor and put it equal to 0. So then I would add 2 and x equals 2. Now, because that's to the third power, I actually have 3 of those same answers. So this is what we call a multiplicity. I'll put an M, a multiplicity of 3, because I have 3 answers repeated, the same answer repeated. And 3 is an odd number, which means I'm going to have a swish at x equals 2. So we'll graph the 0 at 2, and then I'm going to put an S here. I'm going to get a swish through that point. All right, the next factor is an x plus 1 equals 0. Therefore, x is going to equal -1. Because it's squared, I have 2 of those. So I have x equals -1 twice. This gives me a multiplicity of 2. I have the same answer twice. And 2 is an even number. So at -1, I am going to get a B for bounce. And let me plot the 0. So there's my 0, and I'm going to get a bounce at that 0. Even multiplicity bounces, odd multiplicity swishes. And I'll show you what a bounce and a swish looks like in just a moment. So in order to sketch the graph, let's go through what you need. You need the ends, which side is up and which side is down. You need the zeros, and here are my 2 zeros. And then the last thing that I like to get is the Y-intercept. So the Y-intercept, how you find the Y-intercept again is you simply plug in 0 for x. So g of x, or I can call g of x y, y equals 2 times 0 subtract 2 cubed times 0 plus 1 squared. And this is going to give me y equals 2 times -2 times -2 times -2 is -8 times 1. And so the y-intercept is -16. That happens to be off my graph. It's way down here. Let's just plot it anyway. So -16 is the y-intercept. Now, when you're ready to draw your graph, so you have all these important things, then you're going to do roller coaster. So you're going to go nice, smooth graph. It's going to be a little bit hard for me to graph on this board, but a bounce means you hit the point and you bounce back in the same direction. So we are not going to go through that point. Now, I don't know where I turn, but I did know that I went through -16. So I had to turn pretty far down. and then you swish through that point, has a little bit of a curve, and then you rise forever. So this is just a quick sketch of that graph. It doesn't look so awesome because it's a little bit bumpy, but nice smooth roller coaster graph. So looking at the graph one more time, I do not know where I turn. So I don't know the minimum or the relative minimum because I don't know exactly where I turn. But this is a pretty good sketch of this graph. And if you wanted to go look at it on your graphing calculator, you could check it on your calculator to see how close you were. All right, domain. So the domain is going to go from negative infinity to infinity, left to right forever. The range is going to go low to high forever, negative infinity to infinity. Yes, this graph is continuous. It's also what makes it a polynomial is because polynomial graphs are always continuous. Symmetry means is it odd, even, or neither? And so I would say there's no symmetry. Boundedness, no, I cannot box it in, so it's none. Local extrema. So the local extrema is going to be this very high point. So I know that the local max is going to be at 0, 0. The local min, that point you would have to find on the calculator. Would be the only way to find the exact. So I'll put CALC for calculator if you want to use your calculator and figure out that one. And then absolute extrema are your ends. And here are your end behaviors right here. The limit as x approaches negative infinity, f of x equals negative infinity. The limit as x approaches infinity, f of x equals infinity. So those are your absolute extrema. Asymptotes, there are none. All right, let's try one more of these. So this graph is not in factored form, but we can still do a sketch of it. So looking at this, the first thing we're going to always do is look at the degree. The degree is this 3, and so we have an odd degree, which means one side will be up and one side will be down on the ends. The leading coefficient, there's no number in front here, and so basically that's a 1. The leading coefficient is positive. Because of that, it's just like my other graph. The right side will go up and the left side is going to end going down. Now, in order to find the zeros, we take the original equation, we set it equal to 0, and then we're going to have to factor to find the zeros. So I can factor out an x squared. That leaves me x subtract 2, which equals 0. So now I have x squared equals 0 and x subtract 2 equals 0. So I have a 0 at 0 and a 0 at 2. So a 0 at 0 and a 0 at 2. I'm plotting those on my graph. Now let's look at multiplicity. Because this is a squared, I actually have this same answer twice, which means the multiplicity is a 2, and 2 is an even number. That's going to give me a bounce at 0. X equals 2 is just one answer. One answer is a multiplicity of 1, and 1 is odd. That means I'm going to get a swish at that 0. So last thing I like to do is find the y-intercept. This graph already has the y-intercept. It's right here at 0, 0. So now I'm ready to sketch. Remember, it's a roller coaster, nice smooth curves. So we go nice smooth curves. You're going to hit this and bounce, which means you do not go through the x-axis. You hit it and go back below. We don't know where we're going to turn, but we are going to turn and then we're going to swish. There's just a slight bend through that point. That's why I call it swish. All right, so again, I don't know exactly where I turn without the calculator, but this is a really nice sketch. And if you were to check your calculator, it would be pretty close. So the sketches, we want the ends to go in the correct direction. We want the zeros to be correct. We want the Y-intercept, and that's going to give me a nice sketch. All right, so let's talk about all the characteristics of the graph. The domain is going left and right forever, so negative infinity to infinity. The range is going low to high forever, negative infinity to infinity. So the increase, decrease. In increase, I've highlighted the graph in green. So here's where it's increasing. The decreasing is in the blue. When listing the increase, decrease, you're going to list it over the domain. And so the increase is going to go from the left, negative infinity, until we get to x equals 0. So the graph goes from negative infinity until we get to 0, union, and then we're going to increase here again. Now, when I stopped the video, I found this minimum. So this is a minimum, and I found it using the calculator. And I got 1.333 and negative 1.185. So increase, you always use the domain. So I am going to use this x value to where it's going to start increasing again. So the increase is going to start at 1.333, and it's going to go to the right forever. This is increasing to the right forever to infinity. Now the decrease is this part in the middle, and the decrease is going to go from, kind of out of room, let me erase this. There we go. So the decrease is going to go from 0 until I get to this x value, which is 1.33. Let me look at my calculator to round 3 places. It rounds 3 places as 1.333. And that's the decrease. And again, you can't find how low this dip is unless you're using a graphing calculator, all right? Boundedness, this graph is not bounded, and I know there's no space there, but boundedness is none. You can't box it in. The local max is this point right here. Let me highlight it in yellow. So here's the local max, and then down here is the local min. And so the local max, you can write it as an ordered pair, or you could just write the y value. So the y value for the local max is 0. The y value for the local min is going to be negative 1.185. As far as the absolute extrema, that's going to be your end behavior. So if you look to the left, I'm looking at that end behavior right there that I circled, and to the right, the end behavior up here. So the limit as x approaches negative infinity, f of x equals negative infinity. The limit as x approaches infinity, f of x equals infinity. And there you go. Let's try this one, finding the zeros. This time, the function is not in factored form, and that is okay. So the first thing we're going to do is just look at the degree. We're not going to add these together because it's not in factored form. So we're just looking for the highest exponent. The highest exponent is the degree. So in this case, the degree is 4. And what I care about is 4 is an even number. So the degree is even. And then the leading coefficient is 1. And what I care about the leading coefficient is that it's a positive number. And so if I have even and I have positive, I know that both of my ends are going to be going up together. All right, so the next thing I'm going to do is I want to figure out what the zeros are. So I can take x to the 4th, subtract 5x squared plus 4. I can set it equal to 0, and I'm going to find those zeros simply by factoring. So I know that x squared times x squared is x to the 4th. I have to multiply to get 4, but add to get -5. So that's going to be 4 times 1, and both of those would be negative. So this gives me x squared subtract 4, and x squared subtract 1 is equal to 0. Now these are both a difference of 2 squares. So here I have x plus 2, x minus 2, x plus 1, x minus 1 equals 0. So you would take each of those factors, set them equal to 0 using the zero product property, and then you can just figure out what x equals. So if I set each of those equal to 0, I get x equals -2 when I subtract the 2. I get x equals 2 when I add the 2. X equals -1, subtract the 1, and x equals +1. Now, all of these are different solutions, different zeros, which means all of the multiplicities are 1, and 1 is an odd multiplicity, and odd multiplicities give me a swish. So you come up to the graph, you graph -2, plot the 0, +2, -1, and +1. And those are my zeros. The only other thing I like to do is find the y-intercept. So in order to find the y-intercept, all you do is plug in 0 for x. So if I have f of 0, it's going to give me 0 to the 4th power minus 5 times 0 squared plus 4. And you can see that when this function is in standard form, the y-intercept is always the constant term. So here's the constant term, and that's also the y-intercept. So something to know when it's in standard form. So I'll come here and I'll go up 4 and I'll plot the y-intercept. Now from there, you're just going to carefully roller coaster it where you're doing nice, smooth, continuous curves. You start up and you end up. So I might start a little bit closer here, and you're going to go through the 0, turn around, go through the 0, and then through the y-intercept, turn around, go through the 0, and through the 0. Now again, this is a sketch. I don't know how low I dip. So I'm going to put question marks there because I don't know how low that I'm going to dip on there. But it basically kind of looks like a W, all right? And that's just a sketch. So when you draw a sketch, it doesn't have to be perfect. You could use the graphing calculator to see that it matches up. But what is important to me? It's important that the end behaviors are both going up. It's important to me that you found the zeros and that you did swishes through those zeros. Again, swish means you go through the point, through the point, through the point, through the point. And it's important to me that you found the y-intercept. All right, so just to review one more time, what's important when you're doing a sketch? Number one, it's important that you find the zeros and their multiplicity. Multiplicity tells me swish or bounce. All right, again, odd is a swish. The second thing that's important to me is that you have the y-intercept. And how you find the y-intercept is you simply plug in 0, like I did here for y, and for x, and find y. So the y-intercept is 4. And the third thing that's important to me is that you know the absolute end behaviors. All right, I'll just put in end B for end behaviors. And that's that both of these ends are going up because the leading coefficient was positive and the degree was even. So those are the characteristics you're going to need to know when you're sketching a graph.